Looking at another related rates problem, a study prepared by the National Association of Realtors estimates that the number of housing starts in the Southwest is given by N of T, which is in units of a million. I'm giving my first unit here. So N of T, if that's 5, that means 5 million housing starts. Over the next 5 years is related to the mortgage rate. R of T is given as a percent per year. So if R is 3, that means 3% mortgage rate. And then we have the equation that relates them. And T is measured in years. So last time we were changing each week in example 1. Now we're going to be changing each year. So let's set up kind of our table here. Instead of having X, P, and T like last time, we have a mortgage rate, an R. We have an N. That capital N is the number of housing starts. And then we have our T that we're changing with respect to. And we just want to put units on these, and then we'll figure out what they equal. So R is the percent mortgage rate per year. N is the number of housing starts, and this is given in millions. So million housing starts. And then my last piece, T, my measure of time is in years. So I have my units, and I have my 3 things. It's always 2 things changing with respect to time. So here we'll have a dr dt and a dn dt in our derivatives. So we just want to fill out what we know. And our final answer, what we're always solving for, is a derivative. So I'm going to figure out what the R percent is given to me in the problem. And then I'm going to figure out N, the number in millions of housing starts. And then we'll also have their derivatives. So we don't really have to do anything with T until we look at the derivatives. So dr dt is going to be how the mortgage rate is changing. So it's going to be changing by a percent is the unit with R, and then the unit with time is years. And dn dt is how the number of housing starts is changing in millions per year. So let's see what we can fill out of this now that we're ready to keep on reading. We have all of our units. So the question says, what is the rate of change for the number of housing starts with respect to time when the mortgage rate is 11% per year? So I'm given a number here. I'm also given a question. What is the rate of change in the number of housing starts? So which derivative do you think we're solving for? We're trying to figure out the rate of change, so we're solving for a derivative, in the number of housing starts per year. So I'm not asked how the mortgage rate percent per year is changing. I'm asking the number of housing starts, how that's changing. So I'm going to put my question mark there. We're going to be solving for dn dt. And the mortgage rate is 11% per year. So the mortgage rate that it's set at right now is 11% per year and is increasing at a rate of 1.5% per year. So I have its rate of change. It's increasing, so I'm going to write my derivative as being positive. If it was decreasing, I'd write negative 1.5%. But it's increasing, so we have a positive rate of change, and it's 1.5% per year. So now I want to go ahead and take my derivative. So I'm taking the derivative of 9n squared plus r equals 36, and I'm trying to solve for how the number of housing starts is changing per year. And I see that I have this n missing, but let's see if we need it in order to plug in first. So if I take the derivative of 9n squared, that's 18n, bringing down my power, dn dt. Plus the derivative of 1r is just 1 dr dt. And then we don't want to forget ever take the derivative of the constant on the right side. Derivative of 36 is 0. So just be sure you finish these derivatives. So we took the derivative, and now we're ready to plug in. I need 18 times n, and I'm seeing I don't know what n is. So I'm always solving for a derivative. I'm solving for dn dt. That's what it's asking me. How is the number of housing starts? What's the rate of change of that? So how is that changing? I should already know the number of housing starts. So I need to find n. Anytime you're missing a variable and not a derivative, you should be able to plug into the original to find what you're missing. So I need to find n, knowing that the relationship between n and r is 9n squared plus r equals 36. So I know the mortgage rate right now is 11%, so I'm going to plug that in for r. So 9n squared plus 11 is 36. I'm going to solve for n here. What's the number of housing starts when the mortgage rate is 11%? So I'm going to keep that 9n squared over here. I'm going to subtract 11 from both sides, so 9n squared is 25. Now I'm going to divide by 9, so n squared equals 25 over 9. And lastly, I'm going to take the square root of both sides so that I get n is plus or minus the square root of 25 over 9. Always have to remember that plus or minus. Well, these are nice square numbers, so I'm just going to take the square root of them. So square root of 25 is 5 over the square root of 9 is 3. So we have two n values for that one mortgage rate. So either there were 5/3 million housing starts or negative 5/3 million housing starts. And you can have a negative number of houses being built. So this is going to be a positive 5/3 million housing starts when the mortgage rate was 11%. So whenever you're missing a variable, plug into the original function that you're given. So I have 18 times 5/3 times dn dt, which I don't know. That's the only thing I can't plug in for, is whatever derivative I'm asked for, plus 1 times dr dt. dr dt, our rate of change, we are increasing by 1.5% per year. So I'm going to put a 1.5 there. And see how upping the mortgage rate affects the number of housing starts. So I'm just going to multiply these together. 5/3 of 18 is 30. dn dt plus 1 times 1.5 is 1.5 equals 0. And I need to solve for dn dt, so I'm going to subtract that 1.5. 30 dn dt equals negative 1.5. And lastly, I need to divide both sides by 30 to get that dn dt by itself. This will cancel. You can divide these in your calculator. So you would get negative 0.05, and I need the correct units on this. So I need the units from n over the units with t. So this is negative 0.05 million housing starts per my units with t is years. So it's changing by negative 0.05 housing starts per year. So we want to determine what that means. Just write a sentence interpreting this. So my housing starts are decreasing because they have a negative derivative, so the function must be decreasing. So what I would say is housing starts decrease. Housing starts will decrease by how much, really? We want to figure out what is negative 0.05 of a million. So I would probably just take this negative 0.05 and multiply it by a million when I do my interpretation. So when I do that, housing starts will decrease by 50,000. And I multiply those together. So 50,000 houses per year. Housing starts are decreasing by 50,000 houses per year as the interest rate, goes up. or increases by 1.5% per year. Which makes sense. We were given that the mortgage rate was already 11% in this area, which is super high. And then they're planning on increasing the mortgage rate. And that's going to make it so that 50,000 less houses will be built each year that they raise that mortgage rate even higher.